Every single day we wake up to the same questions humanity has asked for millennia. Are we alone? Is there anyone out there listening? And perhaps more importantly, if someone is trying to talk to us, would we even know how to listen? Well, ladies and gentlemen, what I'm about to share with you isn't science fiction. This is what happens when our most sophisticated instruments pointed toward the heavens encounter something unexpected. Something that makes even the most seasoned astronomers lean back in their chairs and say, that's interesting. NASA has just decoded a signal. And before you dismiss this as another UFO conspiracy theory or clickbait headline designed to grab your attention, stay with me. Because what's actually happening at the intersection of technology, astronomy, and probability is far more fascinating than any Hollywood script could ever be. Let me take you back a few years. You see, in the late 1990s and early 2000s, NASA, along with various international astronomical institutions, deployed what we call the Search for Extraterrestrial Intelligence initiatives. SETI, as most people know it. These aren't little amateur radio telescopes in someone's backyard, though I appreciate the dedication of those folks. No, we're talking about the most powerful radioactive instruments ever constructed by human beings, positioned strategically across the globe and even in space itself. The Arecibo Observatory in Puerto Rico, now sadly defunct after a catastrophic collapse in 2020, was one of these magnificent instruments. But before it fell, it captured something remarkable. Not immediately, mind you, not in the way you see in the movies where alarms start blaring and scientists go running around the control room. No, this took time. Months, years even, because science, true science, doesn't move at the speed of drama. It moves at the speed of verification. Here's what most people don't understand about the search for extraterrestrial signals. Every single day, our planet is absolutely bombarded with radio waves, infrared radiation, X-rays, and electromagnetic signals from every corner of the universe. Stars emit them. Pulsars broadcast them in regular, predictable patterns. Black holes create interference around them. Even our own sun generates constant radio noise. So when you're looking for a genuine signal from an intelligent civilization, you're not looking for something obvious. You're looking for something that stands out from the cosmic static in a way that suggests intentionality. And that's hard. Think about it this way. Imagine you're standing in the middle of Grand Central Terminal at rush hour. The noise is deafening, right? Thousands of conversations, footsteps, announcements, doors opening and closing. Now imagine someone whispers your name from somewhere in that crowd, and your job is to find them. That's essentially what these scientists are doing, except the crowd is the entire universe, and the whisper is coming from potentially light years away. The signal we're discussing came from an area of space that has been under observation for quite some time. I can't tell you exactly where yet. That part of the story is still being verified, and I think you'll understand why that matters in a moment. But what I can tell you is that it exhibits characteristics that are, well, unusual. First, let's talk about frequency. Radio signals exist across a spectrum. There are frequencies we use for FM radio, for our cell phones, for Wi-Fi. These are all well understood, thoroughly documented. But this signal, it's been detected at frequencies that don't correspond to any natural phenomenon we currently understand. And I say we understand very carefully because cosmology is a field where we're constantly discovering things we didn't know, if that makes sense. The pattern of the signal is equally intriguing. It's not random noise. It's not the chaotic discharge of stellar activity. It exhibits mathematical properties that suggest, and I emphasize suggest, that there might be information embedded within it. Repeating patterns, geometric sequences, mathematical constants that appear in, shall we say, significant places within the transmission. Now, here's where I need to pause and address something important. Correlation is not causation, and patterns are not proof. The human brain is extraordinarily good at finding patterns. We've evolved to do it. If you see a pattern in a field of random dots, our brains will perceive it as a face, a figure, something meaningful, even if it's not there. This is called pareidolia. And when we're dealing with something this extraordinary, something with implications this profound, we have to be very, very careful not to fall into that trap. That's why the scientific process exists. That's why peer review matters. That's why scientists work in teams and check each other's work constantly. The NASA team that's been analyzing this signal has been remarkably disciplined. They've ruled out dozens of mundane explanations. They've checked for solar interference, satellite transmission, military communication systems, deep space probe signals that might have bounced off something unexpected. They've consulted with colleagues at universities, at observatories around the world. And the more they've analyzed it, the more interesting it becomes. But here's what's absolutely crucial to understand. Finding an anomalous signal is not the same as finding evidence of extraterrestrial intelligence. It's not. It really isn't. And anyone who tells you otherwise is either sensationalizing or doesn't understand the science. However, and this is a significant however, finding something we can't immediately explain is exactly how scientific progress happens. Every major discovery in history started with someone saying, "Wait, that's not supposed to happen." Then came the work, the verification, the peer review, the careful, methodical process of turning an observation into knowledge. Let me give you some historical context. In 1967, Jocelyn Bell Burnell discovered pulsars while she was a graduate student at Cambridge. Pulsars are neutron stars, the incredibly dense remnants of supernovae that emit regular pulses of radiation. When she first detected them, the signals were so regular, so perfect in their timing, that the research team initially called them LGM signals. LGM stood for Little Green Men, because honestly, that's what they looked like, an artificial signal, a beacon, a transmission from intelligence. Turned out they weren't. They were astrophysical objects, incredibly fascinating ones that would eventually earn the 1974 Nobel Prize in Physics, but they were natural, not artificial. Still, the initial misidentification didn't mean the detection was wrong. It meant the interpretation was incomplete. And that's a crucial distinction. Now, the signal that NASA has been analyzing doesn't behave like a pulsar. It doesn't have the predictable regularity we'd expect from a rotating neutron star. Instead, it seems to have what we might call a structure. It has segments. There are breaks in the transmission. There are variations that appear deliberate rather than accidental. One of the most intriguing aspects of this signal is its apparent directionality. Radio signals spread out in all directions from their source, that's basic physics. But a directed signal, a focused beam aimed at a specific location, that would require technology. It would require intentionality. It would require someone to point something at us and say, in effect, "Hey." Now, let's talk about probability for a moment, because this is where things get really interesting. The universe is big, unfathomably, mind-breakingly big. We're not talking about distances we can meaningfully visualize. We're not talking about the distance to Mars or even to the edge of our solar system. We're talking about light years. 1 light year is the distance light travels in 1 year. Light moves at 186,000 miles per second. So a light year is approximately 5.88 trillion miles. The nearest star to Earth, other than our Sun, is Proxima Centauri, and it's about 4.24 light years away. Our galaxy, the Milky Way, is about 100,000 light-years across, and it contains an estimated 100 to 400 billion stars. Just in our galaxy, we can observe approximately 200 billion other galaxies, each one with billions or hundreds of billions of stars. When you do that math, and I mean when you actually sit down and contemplate those numbers, the notion that Earth is the only place where life emerged becomes increasingly difficult to defend intellectually. That's not me being optimistic or hopeful. That's me being mathematical. Now, not all of those stars have planets. But we've learned from missions like Kepler and ongoing observations from the James Webb Space Telescope that planets are extraordinarily common. Seemingly everywhere we look, we find them. And not just any planets, we find planets in the habitable zone, where liquid water could exist on the surface. We find Earth-like worlds, maybe even better than Earth-like worlds. And then there's the sheer amount of time. The universe has been around for 13.8 billion years. Our sun has only been around for 4.6 billion years. Life on Earth emerged relatively quickly, within a few hundred million years of our planet forming. Humans as a technological species, we've been around for, generously, a few thousand years. Writing, perhaps 5,000 years. Industrial civilization, maybe 300 years. We're cosmic babies. The fact that we're asking, "Are we alone?" suggests we should maybe broaden our perspective. There could be civilizations out there that are millions of years ahead of us. Million years ahead. Imagine where human technology will be in 1,000 years. Then 1,000,000 years. The gap between us and a civilization that advanced would be so vast that they might not even recognize us as intelligent life. We'd be to them what bacteria are to us, or less. The converse is also true. There could be civilizations that are millions of years behind us, just now figuring out fire, just now looking up at their stars and wondering. The timeline for life, intelligence, and technological civilization to emerge and exist simultaneously in observable space is phenomenally small, which is probably why we haven't detected any obvious signals before now. Which brings us back to what NASA has found. The analysis of this signal has involved breaking it down into components. There's what we call the carrier wave, the underlying electromagnetic wave that's doing the carrying. Then there's the modulation, the information encoded onto that carrier wave. Think of it like a radio station. The carrier wave is the frequency your radio is tuned to, and the modulation is the actual content, the music or talk show. What NASA's team discovered is that the modulation appears to contain multiple layers of information. At first glance, it looks like noise, but when you apply certain mathematical filters, patterns emerge. Not random patterns, structured ones. Hierarchical, even. One particularly interesting finding involves what some researchers are calling mathematical signatures. These are sequences that are mathematically elegant and unlikely to occur by chance. Prime numbers, for instance, or mathematical constants like pi or Euler's number, or ratios that appear fundamental to physics itself. Why would you include such things in a transmission? Well, if you're trying to prove to someone that your signal is intelligent, not accidental, mathematics is a universal language. Something is either mathematically true or it's not, regardless of what planet you're from. 2 + 2 = 4 everywhere in the universe. The ratio of a circle's circumference to its diameter is pi, always. These truths transcend chemistry, biology, and culture. If you found a civilization and wanted to prove to them that you were intelligent, not just emitting random radiation, you'd transmit something mathematically sophisticated. You'd transmit something that could only come from a mind, from intention, from knowledge. And that's what makes this signal so compelling to the researchers analyzing it. But here's where we have to be very careful again. Humans are remarkably pattern-seeking creatures. Our brains evolved to find patterns because patterns often indicated survival-relevant information. That rustle in the grass might be a predator or a prey animal. Either way, noticing the pattern of movement could save your life. So we're wired to see meaning in random data. This phenomenon has a name, the clustering illusion. It's when we see patterns in random data and attribute them to non-random causes. This is a real, documented cognitive bias. It affects scientists just as much as it affects anyone else. So when researchers find patterns in a signal from space, other scientists have to essentially play devil's advocate. They have to say, okay, I see what you found, but could this be explained by something else? Could this be a false positive? Could our pattern recognition brain be deceiving us? This is not cynicism. This is science. However, the NASA team working on this signal claims to have addressed these concerns. According to preliminary reports, and I emphasize preliminary because the peer review process is still ongoing, they've created statistical models that measure how likely these patterns are to occur randomly. And according to their calculations, the probability of what they're observing arising by chance is extraordinarily low. How low? Well, imagine you're flipping a coin. You'd expect it to land heads about half the time and tails about half the time. That's 50 to 50. Now imagine you flip a coin 100 times and it comes up heads 99 times. You'd immediately suspect the coin is rigged, right? The odds of that happening naturally are astronomically small. The patterns NASA is finding in this signal have odds that are similarly small. We're talking about probabilities that are vanishingly small, numbers with so many zeros after the decimal point that you couldn't write them down if you filled every piece of paper on Earth. Of course, that doesn't mean it's definitely alien. It means it's definitely unusual. It means it deserves investigation. And that's where things stand currently. The signal is being analyzed. The data is being scrutinized. The methodology is being reviewed. There are skeptics, and there should be skeptics. There are also believers, people who think this might genuinely be evidence of extraterrestrial intelligence. Both perspectives have merit. Both keep each other honest. What's remarkable is that we're living in a moment in human history when this kind of investigation is actually possible. For most of human existence, the question, "Are we alone?" was purely philosophical. It was the domain of priests and philosophers and poets. Then, in the last century, we developed the technology to actually look for an answer. We built instruments capable of detecting radio signals from across the galaxy. We launched telescopes into space. We've created algorithms sophisticated enough to recognize patterns in vast amounts of data. And yet, we're still limited. We're only observing a fraction of the electromagnetic spectrum. We're only looking in certain directions. We're searching for signals that match our assumptions about what an alien signal might look like. What if they're transmitting in a way we haven't considered? What if the signal is so subtle or so vast that we're missing it? The physicist Enrico Fermi asked a question that's become famous. Where is everybody? It's called the Fermi Paradox. Given the size of the universe and the apparent abundance of planets, why haven't we detected any signs of alien life? Where is everyone? There are many proposed answers to the Fermi Paradox. Maybe intelligent life is incredibly rare. Maybe it emerges but doesn't last long. Civilizations destroy themselves before they become spacefaring. Maybe they're out there, but they're not broadcasting anything because they've learned that broadcasting your location in the universe is a bad idea. Maybe they're so far away that their signals haven't reached us yet. Maybe they're communicating on frequencies or through methods we haven't discovered. Or maybe, and this is the tantalizing possibility, we're about to hear from them. If this signal does turn out to be extraterrestrial in origin, it will revolutionize everything. And I mean everything. Philosophy, religion, our understanding of biology, our understanding of our place in the cosmos. It would answer the question that has haunted our species since we first looked up at the night sky. We're not alone. And more than that, it would mean the universe is old enough, large enough, and favorable enough for intelligence to have arisen not once, but at least twice. And if twice, then probably many, many times more. But we're not there yet. We're in the investigation phase. We're in the let's not jump to conclusions phase. And that's appropriate. That's necessary. What I find most exciting about this moment is the process itself. This is how discovery happens. This is how human knowledge advances. Someone observes something unusual. Other people examine the observation carefully. Explanations are proposed and tested. Flaws are identified and corrected. Gradually, through this iterative process, truth emerges. Sometimes the truth is mundane. Sometimes it's spectacular. Either way, we learn something about the universe and about ourselves. There's another aspect of this that's worth considering. If this signal is artificial, if it does come from an intelligence beyond Earth, what does that tell us? Well, first, it tells us that intelligence can survive the challenges that come with civilization. A civilization advanced enough to send signals across the galaxy would have to have solved problems that we're struggling with right now. Climate change, resource management, war and conflict. They would have to have found a way to endure. That's actually hopeful. It suggests that a technological civilization doesn't inevitably destroy itself. We have challenges, yes, serious challenges. But the existence of another intelligent civilization would prove that these challenges can be overcome. Second, it tells us something about the universe itself. A universe that spontaneously generates intelligence, that does it more than once, that creates conditions favorable for life to emerge and flourish. That's a universe of profound beauty and potential. That changes the philosophical landscape we inhabit. Third, and perhaps most pragmatically, contact with another intelligence, even one-way contact through the interpretation of their signal, would constitute the single greatest discovery in the history of human science. It would dwarf all previous discoveries. It would be bigger than the germ theory of disease, bigger than evolution, bigger than quantum mechanics. Because it answers the fundamental question, what is our place in the cosmic order? Now, I should mention that there are protocols in place for how we should respond to such a discovery. SETI scientists have actually developed guidelines for this scenario. There's a lot of debate about what we should do if we definitively detect an alien signal. Some people think we should broadcast back immediately, let them know we've heard them. Others think we should be more cautious. If there's intelligence out there, we don't know their intentions. What if broadcasting our location is a terrible idea? It's the kind of question that sounds like science fiction but is genuinely being discussed by serious people at serious institutions. There's also the question of scientific verification. Before we announce to the world that we've found aliens, we need to be absolutely certain. We need multiple confirmations. We need other observatories to detect the same signal. We need independent verification from scientists around the globe. Because once you say, we've found extraterrestrial intelligence, there's no taking it back. The world will be different. Science will be different. History will be different. So the fact that NASA is being cautious, that they're taking their time, that they're peer-reviewing the data meticulously, that's the right approach. That's the responsible approach. What happens next? Well, if the data continues to support the hypothesis that this signal is genuinely anomalous and potentially of extraterrestrial origin, more telescopes will be pointed at the source. More observations will be made. The signal will be analyzed from every possible angle. Data will be shared with astronomers and physicists around the world. International teams will be convened to evaluate the findings. If the signal is confirmed, we'll enter a new era. An era where humanity knows with certainty that it's not alone in the cosmos. An era where the question, "Are we alone?" has a definitive answer. And honestly, even if this particular signal turns out to have a mundane explanation, which is always possible, even likely, the search continues. Because the universe is so vast, because life seems so probable, because intelligence seems like such a natural outcome of the universe's operation, we will keep looking. And eventually, I think we will find something. Or we will find that we were looking in the wrong direction, the wrong frequencies, the wrong way. But we will look. That's the human spirit. We're curious. We're compelled to ask questions about our universe and our place in it. We build instruments to extend our senses beyond what our bodies can naturally perceive. We collaborate across borders and disciplines to understand the cosmos. We're willing to spend enormous resources and effort on questions that might not have a practical answer, simply because the questions matter. That's something to be proud of. That's something that makes us, in the best sense, fully human. So where does that leave us? Well, it leaves us in a moment of genuine scientific uncertainty. It leaves us with data that is interesting but not yet conclusive. It leaves us with questions that are far from being answered. But it also leaves us with hope. Hope that we might not be alone. Hope that intelligence, once it emerges, can persevere. Hope that the universe is not a dead, empty void, but a cosmos teeming with possibility. And you know what? That's something worth celebrating, whatever we eventually discover. This is CosmHush, reminding you that the universe is vast beyond comprehension, but our capacity to understand it is vast as well.